Okay, let's face it. I really suck at typing. I mean, I can usually type like 70 words per minute, but by any standard, that's not the fastest you can go. And in addition to that, I recently switched from a German to an English layout keyboard. And especially with those special characters, I have some problems. So I looked around for solutions, and of course, there are a lot of text typing applications where you can learn how to type and get faster at it. There's TypeRacer, which I really enjoy. There's Keyber, which is also quite nice. There are a couple of offline applications as well. But I wanted something for myself. And I thought, why not do it in Rust? This is not really low level or maybe not even interesting for most people, but it's something that I need and something that I want to build. And that's what this show is all about me hacking on some Rust and explaining something on the side. Maybe some of you want to follow along, so this is why I will add a caption to the URL where all the code is hosted. But for the rest of you, you might just lean back and be entertained while I write some Rust code. Let me get my laptop. Yeah, by the way, I completely forgot that you're watching Hello Rust, and this is episode number 5. And yes, I'm still Matthias Endler. Surprise. The attentive viewer might have noticed that I'm dressed a little differently, because the first time I tried to record the session, I completely failed. The reason was that, I somehow didn't pick the right path to go down, and it felt a bit awkward along the way. So I just decided to record that thing. The microphone was also off, so yeah, bad luck for me. Anyway, let's just get started. This is the ggez core repository, which is the library we're going to use to build our application. It has a lot of different features, file system abstraction to read resources, 2D rendering. It can play audio, all that nice stuff, font rendering, really cool stuff. Also has a few examples. I guess they will come in handy along the way. There's some Hello World example here for a start, and it seems like it's rendering some text. So yeah, amazing. I guess we can just get started by cloning this repo. Let's clone it. Open it. You can run any example by saying cargo run minus example hello world. And boom, we have our nice sample application up and running. You can see there's some text and, well, fascinating. I guess we can build on top of this. And now if I type some letters here, nothing's happening. So I guess this is what we need to implement. What just happened? I show you the example code that we just ran. First, we import ggez, which is this game interface library kind of thing with all the dependencies. Here we have a struct which is kind of important. It's called main state. Everything here is representing the game state. And I guess we will extend that to keep our own state. Then we have some implementation of that. We load our font, we create some text, we create some main state instance, and we return OK. And then the magic happens in the event handler. which we can implement for our state. And there's a couple of methods. One is update, which, yeah, I guess updates things on our game state, and it returns a game result type. Like all of those methods basically return a game result type. And then we have some draw method, which takes care of the drawing every single frame. I guess this is quite a good start. To wire that up, there's also a main function here, which loads some default config, some name for the application. Yeah, it gets some magic files from the file system to mount our resources. We don't need any resources, I guess, maybe for audio later, but not right now. And yeah, then we just trigger our main state and we run the event loop, which is very, very common for game engines. There is usually an event loop. Yeah, but there's one problem. Where is our text input? So remember, what I want to write is some kind of text typing training application. So we need some way to get some keyboard input. Well, look, there's an example called input test. And it seems like it does all sorts of input stuff. So mouse input, mouse wheel input, text editing input, and so on. What if we run this? Okay, some magic circle, we can't see much, but ooh, look at this. Mouse motions everywhere. There's also keys, so if I say hello, hello, then you see the text input and even some magic events. So this was as far as I got in the tests. And the problem was that I focused on this key input event. So the thing that I implemented was this key down event, and it gives you some meta information on what key you pressed. The key code, the key modulator key, so for example shift, and if it was a repeated input. That's quite handy, but if you look at the example, then sometimes if you have a special character, let me start that up again, and for example you have a slash, then you will get this as an input. It says key released slash and also key pressed slash with a modifier key, and it was not repeated. And what I want to do is, when I type my letter, I want to check if it's the letter that I expect. And in case of a slash, I would have to check, is it a slash? But not the name slash, but the actual character slash, which makes things a little bit more complicated. So when I noticed that, I kind of looked up the documentation, and of course there's a better way, which is this text editing event. And actually, there's another string output saying text input slash, and this is the slash that I want to match on. Well, bad luck for me. But I guess what I'm gonna do now is I want to combine those both examples, so hello world and the input test, and work with this to have some kind of keyboard tutor program in the end. Let's start by removing everything that we don't need from the hello world RS, just for some cleanup. I guess what we don't need here is this frame rate stuff, because we don't care about the frame rate right now. It's gonna be abysmal anyway. And I guess the two things I want to focus on is this draw method here and our event handler for the text input. Okay, first we already have some hello world text, but it was a bit big. So let's make that like 20 point. And I guess we need two things. We need our input text and we need the current status. And we can represent the current status as the last correct character that was input. So in our main state, we could have another field saying current, and that can be a usize. And when we initialize our main state, we say, let's put it here, current, and that is gonna be 0. Sweet. And in addition, we don't render our text right away. I guess we can just store it for now in a text field. So I would say let text, and that is going to be a string, equals hello world into, to convert it to an own string. We save it in our main state, but now we need to adjust it here, make it an actual string. And down in our draw method, we cannot really draw our self text anymore. Instead, what ggez is providing is some kind of method to wrap the text around so that it does not go outside of the screen. And that comes in very handy here because, well, yeah, otherwise we would have one gigantic line, but we want multiple lines below each other. So that's gonna be font get wrap. I guess that's how the method is called. And we have two parameters. One is our text as a string slice, and the other one is the length of the text on the screen. And that will return a tuple of the length, which we simply ignore, and the lines iterator, iteration over the lines. I guess we also need some kind of font here. Right, I guess it's self.font.getWrap. And self.font is not defined yet. So we just add it to our main state. Let's say font. And on top we say font graphics font. Now in our draw method we cannot really draw the entire text, but we need to iterate over the lines now and draw one by one. For line in, and we'll borrow that, lines. For each line we now print the text on the screen. So this can be a line now. And our destination point is okay, but only for a start. So let's move that out of the loop. And let's make that a variable here. So let's move it in again and let's say let mutable y equals 10.0. I'm gonna use it here. And after every iteration, we need to increment y now. Y plus, equals 30. Now we need to render each and every single line. So we say let text equal graphics text new, and that takes a context, the text and the font. We have all that. Our context is CTX, the text is line, and the font is self font. And here we don't use line, we want the text instead. And I guess this needs to be a float, since we do an addition between a float and a float in this case then. Okay, does that make sense? I have no idea, so let's just try and find out. Hello world. Okay, we get a couple issues. So one is we expect a reference, but we found some direct font. So we need to borrow that here. Then the draw method also should be a reference, but you can see that it's of type result, so that's not a good idea. I guess we can simply use the carrier operator here to get the OK value in this case, and we borrow that too. And that's one of the things I still have some problems with, because in the languages I've used before, I did not work with borrows at all. And of course they make sense here. We just want a borrow because we don't want to take ownership of the text, and that should also be reasonably fast. But it's just something that I still need to get used to. Okay, so let's try compile again. Booyah! Our text is smaller. Well, it doesn't really wrap around the lines yet, but I guess this is just because there's not enough text, so let's just change that. And let's actually write some Rust code here for a test. So fn main, and that returns nothing, and we have some print line in here. Let's just raw text. Then we have some additional quote and some variables. Simple stuff. But of course here we have special characters, and a way to avoid it is to use raw text, and you just say r hash in front of your string and a hash in the end, and then you can do whatever you want in this string, and Rust doesn't really care. I guess this is still not long enough. Let me add some new lines here. Like this. Like this. Probably not. No new lines for now. Later maybe. Boom, our first Rust code on the screen. But of course, text input still doesn't work. Let's make it happen. Let's get our input method from the input test.rs file. Add that to our event loop. Maybe just right here, just below the draw method. And maybe it already works. Typing some text, sweet. You can see the output down here. What I would like to do now is write this check for our text. And the way I imagine it to work is that whenever I type some text, I want to compare the character at the current position with the text that I expect. So first we get our current position in the text. Let char equals self.text dot chars nth at the self current position. You might be wondering why I'm using chars and nth here. Well, that's because it doesn't need to be ASCII character encoding here. It can also be UTF-8, and UTF-8 has more than 1 byte for one character. So we need to be a bit more explicit here. And we just iterate over each and every char, and we get the nth element, which is our current counter. It's quite straightforward once you get the hang of it. But nth returns some result, I guess. Let's check. That's devdocs again, which I can highly recommend. Okay, nth returns an option. Okay, then we have two conditions. Either we have a next char, or let's call it next char, by the way, or we don't have a next char. And well, if we don't have a next char, then I guess we're done and we quit the application. So instead of doing this, we say match on current, and we have two cases. Either we have some next char, then we got a match, and let's just print match for now. We have a match, and that is our next char. And in the other case, we have no char. We can either say none or underscore here. And we would have to stop the application. So exit. Oops. XT. Exit. Okay. This makes sense. Let's try. Okay, seems to work because our next char is F. In reality, we don't really have a match right away when we match a char. We also need to compare what is the character that we expect. So let's do that. If next char equals text, then we have a match, and we say self.current plus plus. Sweet. But text is a string and char is a character. So I guess we need to convert that into a string. If I'm not mistaken, let's see if that is the case. Okay, first off, yeah, that's the case. And also I have a typo here. Expected expression. Oops. Found plus plus. I thought that's possible. Okay, so I had to write plus equals 1 here. I thought plus plus was also possible. Maybe not. Anyway, let's create a string from this char to string. And now when I type, and I type the correct character, it should actually forward to the next character. So if I type fn, let me add some debug text here. Let's print out the text that we get. And let's print out the next character that we get. Let's do that again. So f is f and n is n. Okay, yeah, perfect. Actually, it does work, but I just haven't printed anything on the screen. So easy. So we have a match. Cool. F n space m. Okay, and when I type something else, it doesn't work. Perfect. Yeah, this is exactly what we want. I guess now we can start coloring the text in some different color so that we can see what we actually typed. And we do that in some kind of shady way, I would say. I'm a big fan of getting something to run first and then iterate and improve it. I guess the easiest thing to do is to copy this block here. Yes, I can already hear you, Grinch, but doesn't matter. I will copy this block and I will just place it here. And instead of text, let's create a new variable called input text. Or correct text? Yeah, I like correct text better. And that is self.text.chars.take self.current dot collect. Let's add a safeguard here, and I want to say I expect a string. That's sometimes a very good practice to define the type here, just because I'm not sure what it should be. So we borrow correct text here. And then we iterate over those lines again, blah, blah. I guess we also need a way to change the color here a little bit. The method is called graphics set color. Oops. Yeah, and takes a color and a context. And color is, let me look up the all sorts of ways to create a new color. So red, green, and blue, and the alpha channel, or they also support colors from tuples. So I guess I will go with this. I say, let's make it a red. Red is always good. Into. I don't know if I have to reset the color later on. Let's just try and see what happens. Probably we'll get a compile error. Not even. Okay, but it was coloring the whole text. But if you look closely, you can see what we type, which is cool, but it's all in red. So I do have to reset the color. I will just do that on top of this line here, and I guess I will set the color to white. Okay. Okay, color is in beautiful white, and now if I type, I actually have something pretty good. I wonder what happens when we try to load a bigger file. Instead of our predefined text here, I guess I want to load a file, and I will just do it inline. Why not? So the way file loading works is I create a buffer, let's say, yeah, let's call it text again. And we read some string. So we create a new string buffer, if you like. And then we open a file and read it into this buffer. So file, open. Let's actually read the source code of ggez. Why not? Source librs. Yeah. And this can fail, so I guess I need a question mark here. And then I get the file back. f.read to end, or maybe not, maybe, into our text, and the text needs to be mutable. Yeah, why not? Maybe something like this. I can hardly remember this syntax. Of course, we need to use standard fs file. What's in complaining about? Yeah, we also need read. So use standard IO read, because that's a trait, and when you use traits, they always need to be in the context. Okay, and here we don't have a borrow, we have a mutable borrow. As I said, borrowing takes some time. Cool, and that expected vector. Oh, I guess it's read to string. Come on. Mute. The file gets modified while being opened. Of course, we set the file pointer and stuff. Wow, that looks horrible, but actually it's what we expected. Oh yeah, and I can already see that we have some input lag here. What is this? Yeah, it takes a while. I guess it's a big file, but also we render the text quite often. I wonder how that looks in release mode. Cargo run -- release. Wow, that was quick. Let's see if it's faster. Well, actually, it is a lot faster. Hash. Yeah, that is actually quite workable. The only thing is that whenever I go to the next line, yeah, it just doesn't work. So I guess we need to fix that. We can fix that in the text input, and we say either the next char is our input text or it's all white space. So I guess next char is white space. Maybe that's a thing. And I guess I want to make some parentheses around that so that it's obvious what's going on. And the text dot chars dot all, and then we say C is white space. See, need to type some stuff, and yeah, it wraps around flawlessly. Just my typing, which is a bit absurd, but yeah, I don't know what's going on here. Maybe somebody can explain. That's weird. Oh yeah, I guess that's because of the line wrap, because the following line is quite long, and so the text in the original text wraps around, but my current input text is not long enough to wrap around, so that's why. No, I guess it's enough for today. So what have we learned? We've looked into ggez, which is a very nice game framework. We've built some application with it where we can actually learn typing. Of course, that's just a start, so yeah, I don't know, there's a lot of features missing. Maybe I will work on this, maybe not, who knows, but it was definitely fun to build. If you like this episode, then you might want to subscribe to the channel. If you feel very, very generous, then today is your day. You can support me on Patreon. There's a link somewhere in the description, and I would be very, very happy if you could support me on that mission. And apart from that, I guess that's it for this episode. I hope I see you soon, and yeah, stay tuned and have fun with your hacking projects. See you around.